Hello everyone. Uh, this project presentation about the pre-symptomatic detection of COVID-19 from smartwatch data, and this project is presented by Brhanu and SuhyeonP. The introduction part is COVID-19 pandemic has infected tens of millions of people, and it also caused above 1 million people deaths and worldwide. But it's currently nucleic acid biotests are used for active infections, and whereas a serological data method has been used widely for the past infections and as well as and it could be used for the epidemiological data. Uh, Real-time polymerase chain reaction diagnostics has some limitations, as you know, and the first one is it's very expensive, and it takes 1 up to 2 days, which is a time delay, and it used an excessive amount of reagents, so and some pointers and shortage of reagents and would be happen. Uh, the most important limitation is it couldn't be accessible in less infrastructural area, and it also needs a trained personnel, and this also hinders the fast detections and early treatment of um, the COVID-19 detections. So the timely and accessible detection method is urgently needed now. Therefore, wearable devices and specifically smartwatches are designed to identify COVID-19 patients and before symptom onset. And this is the first smartwatches and designed and before symptom onset. And it is because of and uses the vital physiological parameters and such as in heart rate and sleep and steps. Uh, when I come to the methods, it has 4 parts, and the first part is participant or recurrent methods, and the 5,262 participants were involved, and this includes confirmed COVID-19 patients, high-risk exposure patients. This means the close contact with the confirmed patient, and also based on the occupational rules, and individuals with unknown respiratory illnesses other than COVID-19 disease, and persons who has no any reported illnesses has been included in the uh, retrospective study. All participants were asked to wear an fitness trackers daily, and these were informed to download my PhD app, and they're required to send their information through this app. In addition, the long-term wearable data was collected before the COVID-19 pandemic. The second is metadata collections and surveys, and the general information and the demographic information, medical history, COVID-19 status, daily symptom tracking surveys through the PhD app, and also one-time past illness surveys. And it can be included since November 21/9. The study analyzed the data from COVID-19 and non-COVID-19 illnesses, and wearable device and long-term collected data were also appropriate for analysis. This is the PhD app and the smartwatches. And the other procedures and wearable device data was processed, and metadata processing was done, and the 2 detection methods has been proposed, and resting heart rate difference offline anomaly detection and heart rate over steps anomaly detection offline method has been proposed, and to customize this, and activity sleep analysis was done along with the heart rates, and custom online detection system was developed, and the visualization method was included in order to verify it's the correct order. For the next is continue.
So they investigated the use of a wearable device for the early detection of COVID-19 in a retrospective manner and also present an approach for using wearable device detected physiological parameter for real-time health monitoring and surveillance. They investigated whether smartwatches could be used to detect COVID-19 at an early pre-symptomatic stage. Participants were asked to log daily symptoms and to share their fitness tracker data via the study app. And the data types collected include heart rate, steps, and sleep over a period of several months. So two infection detection algorithms were developed. And summary, the right figure is the summary of data collected from 32 study participants who reported a confirmed diagnosis of COVID-19 with a symptom onset and test date. Each and the figure B is the overlapping bar plot depicting heart rate metrics and trimming of infection detection from RHRD and HROSAD with respect to the infection detection window for COVID-19 positive participation. The 32 individuals fell into three types, and Group 1 included who were able to detect disease primarily as a single evaluated period, and the others are shown who detected evaluated heart rates and the having established aberrant physiological signals associated with the COVID-19 illness. They investigated whether COVID-19 also affected behavior, especially steps and sleep duration. The sleep duration significantly increased after the onset of outlying RHR diff signal, but only with missing data imputation. These results indicate that COVID-19 illness alters steps and sleep patterns, which can be tracked using a wearable device. And using these data, they developed algorithms that detected elevated RHR and outlying heart rate steps measurements, usually in advance of symptoms. The early times of detection were generally consistent with the latent period of pre-symptomatic illness reported previously. So data on reported respiratory rate and blood oxygen saturation are expected to be particularly useful in COVID-19 prediction, although the disease is quite heterogeneous in its physiological presentation.